Our first example is going to be this integral. Integral of sine cubed of x cosine to the fourth power of x dx. Now, notice how it involves only trigonometric functions. So this is what we call trigonometric integral. How do we solve? How do we approach trigonometric integrals? Well, we usually use substitution method, or u substitution, how we also call that. Now, if I attempt to use substitution for this integral, I can see that I have two options for what, well, at least two options for what u can be equal to. So I'm going to consider both of them. So I'll say option 1. I can let u be equal sine of x, right? And then my second option, option 2, is I can let u be equal cosine of x. Now let's investigate both of them. If I continue with the first option, then differential du equals derivative of sine is cosine, cosine of x dx. Now, my goal is to replace everything within my original integral with u. So it has to be written in terms of u. Now, I can already see how sine of x will become u, right? So it's going to be u to the third power. I will rewrite my integral and I'll start making notes for myself. Okay, so based on this first option, sine of x becomes u. So it's u to the third power, right? Now, how do I introduce du, differential du? Well, if I can find cosine x dx within my integral, then I will replace that with du. Can I find cosine x dx? I can. Oh, you know what? I forgot to put x here. I surely can. Well, because what I have right now is cosine to the fourth power x dx. But then this cosine to the fourth power can be split, right? I can split it up. I can write it this way. So sine cubed x, that's the first one. And then instead of cosine to the fourth power, I can put cosine cubed x times cosine x, right? If I multiply them, then I'll go back to the original cosine to the fourth power, right? And then dx. Now, as I separated cosine, one cosine out of cosine to the fourth power, then now I can see where I have this piece, cosine x dx, that I can replace with du. So that's going to be du. And then once again, sine is u. Well, I'm not done here, right? Because I still have cosine cubed of x, and that also has to be replaced with something in terms of u. Now, what can I do here? Well, if I could rewrite cosine in terms of sine, that would be helpful, because then I would introduce u from here. But can I rewrite cosine to the third power of x in terms of sine? Well, if I recall basic trigonometric functions, I'll remember that identities that relate sine and cosine, they actually involve squares. Let me write down those identities over here. We just refreshed them in the introduction video. So remember that sine squared of x is 1 minus cosine squared of x. In other words, if I have sine squared of x, I can replace that with expression 1 minus cosine squared of x. Or if I have cosine squared of x, I can replace it with 1 minus sine squared of x. Right? So those two basic identities. Now, so if I had cosine squared, I would be good. But I don't have cosine squared. I have cosine to the third power. Well, and even if I separate that, and I will rewrite it as, if I rewrite it as cosine squared of x times cosine, then I will still be left with one cosine that I won't be able to replace and rewrite in terms of u. So I'm kind of getting stuck here. So this portion is the problem. This part is the problem one. Can't rewrite in terms of sine of x. Okay, so we got stuck with this option. Let's see what's the second option I'm gonna provide. Is it gonna be better? Well, let's try. Okay, so with the second option, we're saying then that u is cosine of x. Then differential du is negative sine x, derivative of cosine, right? Is negative sine x dx. Well, let's check what happens with this kind of substitution. So I'm rewriting my integral and I'm making notes. So cosine is now going to be u. Okay, so cosine is u, that part is done. And then if I can find, well, negative sine x dx, that's going to be du. But I guess in this case, I don't have any negatives here, right? So I don't want negative on this side. I'm going to rewrite this little equation and I will divide both sides by -1. So then I'll obtain negative du equals sine x dx. So now it's a little bit easier for me to look at it. So what it means is that if I can find sine of x dx within my integral, I will be able to replace it by negative du, and that's going to be perfectly fine, right? That negative is same as -1. Then I can later put in front of the integral. Let's see, do I have sine x dx? Well, what I have left is sine cubed x dx, but I have no problem, as before, to separate one sine, right? And rewrite it as sine squared times sine. I'll do that. So I'm separating sine cubed into sine squared of x sine x, right? So if I put back together, I will return to sine cubed. Then I have cosine to the 4th power x dx. Okay, making those notes again. Now cosine is u. Oh, I didn't make note here. That's u. U. Now, sine x dx, so that portion, those two together, sine x dx, that is from here negative du, okay? And again, we still have sine squared of x left. How do we replace that and write it in terms of u? Well, if I can rewrite this in terms of cosine, then I wouldn't have a problem because cosine is u. Well, but this time, because it's sine squared, I can use one of those identities, right? From the first identity, it says that if I have sine squared of x, I can replace it with 1 minus cosine squared of x. And that's what we'll do right now. So that is same thing as 1 minus cosine squared of x, right? And because it's now written in terms of cosine, I will be able to replace this cosine with u from my substitution right here. And now look at that. Now everything is in terms of u. 1 minus u, well, it's going to be squared since cosine is squared. Now sine x dx, that's negative du, and then cosine to the 4th power x, it's going to be u to the 4th power. Let's put it all together. Now this negative, I'm going to put in the front. So negative integral. For this first expression, I have to be careful. With this first expression, I have to be careful because since it's a difference, I want to keep it inside the parentheses. So it's going to be 1 minus u to the 2nd power, since it was cosine to the 2nd power, u to the 2nd power. Next, well, that sine and dx will be at the end, right? That's going to be du. Negative is here. Next, I'm going to write this portion. It's u, which is cosine, to the 4th power. U to the 4th power. And at the end, it's du. Okay, now look at the integral. So actually, now it looks like something we can pretty easily integrate, because if you have some kind of algebraic expression like that within the integral, we'll just simplify it, distribute it. Well, multiply it out by distributing, right? So what I mean is that I'll just need to multiply u to the 4th power by this binomial. So negative integral u to the 4th power minus u to the 6th power du. And to integrate that, we'll just use the power rule, right? U to the 5th power over 5. Notice how I'm still keeping the parentheses. It's just all because of that negative sign in front. So if you have coefficient or you have negative sign, keep the result of integration inside the parentheses and then clear those parentheses. Minus u to the 7th power over 7 plus c. I can put c outside. Okay, now I will distribute negative sign, negative u to the 5th power over 5. Negative gives me positive, plus u to the 7th power over 7 plus c. And one last step, don't forget the last step, which is returning to the original variable of integration. So u will be replaced by what we denoted it for. So let's go back to our substitution part. Right here, u is same as cosine of x, so I will be replacing every u with cosine of x. Let's put together our final answer. Negative u becomes cosine. Well, since u is to the 5th power, it means it's going to be cosine to the 5th power of x over 5 plus cosine to the 7th power of x over 7 plus c. And that's the answer. Now, if we summarize the process and if we refresh what we tried at the beginning, remember how we tried different options and one option failed us and the second option worked. What can we learn from our experience here? So we can learn that if trigonometric integral involve trig functions with odd powers, like we had sine to the 3rd power, right? We would want to keep this function and use it later. So in other words, not to use it for substitution, right? We want to keep it for the second step where we would separate it and we would put aside a single factor that would be involved in introducing differential du, and the remaining portion, the one that has to be with an even power now, can be replaced by the other function using trig identities, if that makes sense. Now, as you do more examples, you will naturally figure out that rule. But at first, it's totally fine to try both options and see which one works for you. So it's all going to depend on the powers, which one is odd and which one is even. So once again, the odd power we're going to kind of like put aside and use it later for separating into single factor and another factor with even power, for which we can use trigonometric identities.